Guys, day 79 of the 100 Days of LeetCode. We got a medium problem, very famous medium problem, number 15, three sum. Let's do it. So we're given an integer array nums, and we want to return all the triplets, nums I, nums j, nums k, such that I isn't equal to j, I isn't equal to k, and j isn't equal to k. Basically, we're not reusing the same index, and it goes on to say, and nums I plus nums j plus nums k is equal to 0, and the solution set cannot contain duplicate triplets. So, example 1, we have our input array nums, which has these numbers in it, and basically these two triplets both sum to 0, so we include them in our solution list. Okay. And example 2, we have nothing in the list. We have nothing in our output. Example 3, we have 0. We have nothing in our output. And these two sort of make sense because if we don't have 3 numbers in our input list, well, we can't have, three sum doesn't even make sense. So of course our output is going to be an empty list. Okay, so one more thing I wanted to point out is it says, notice the solution set must not contain duplicate triplets. So even though here, you're going to get a situation where you get -1, 0, and 1, and then when you get to the second -1, obviously you can use 0 and 1 again and still get 0. We don't include that second -1, 0, 1 in the list, right? Since it's already there, we just include it the one time. Okay, so let's do it. So I'm going to use a set. There are ways where you can use a list, but I think if we just use a set, it would be a little more intuitive at the cost of some efficiency. But for now, we'll keep it at a set. And the reason why we're going to keep it as a set is because if we add basically tuples, we're going to be adding tuples instead of lists. It will check whether or not that tuple is already in the set, and if it is, then obviously it's not going to add it because sets do not allow duplicate values. So that is why we are using a set. Now we're going to do nums.sort, and the reason why we're sorting this is because we just want to get a nice, we want to get the list in order, and that will make sense once I go through the rest of the solution. So I'm going to come back to that in a second. All right, so now we're going to say for I in range length of nums -2, and the reason why we're doing -2 is because we need to have triplets, so we need to basically leave space for the second and third number of the triplet in the list. So the first number, which is going to be represented by the number at the ith index, I is only going to go up to the third last index, which is why we're doing length nums -2. Okay, so we've got that. Now what we want to do is we want to create a left pointer, and we're going to set that to I +1. We're going to create a right pointer, and we're going to set that to the length of nums -1. So L, we want to be the next number over from I, and then R is going to be at the end of the list for now. And the reason why we're doing that is because once we have our first number I, and when I say our first number I should clarify and say once we have our first number, which is at the ith index, we're basically going to do a 2-pointer solution over the remaining indices, and that's going to help us with some efficiency gains there. Okay, so once we have declared our 2 pointers inside the loop, we're going to create another loop, and we're going to say, well, L is less than R. So while L is less than R, we're going to store basically our current triplet, the sum of our current triplet, I should say, in a variable. We'll call it cur, and we're going to say nums I plus nums L plus nums j. And that's going to give us our current value. Now, because the list is sorted, we'll come back to that nums.sort again. Because the list is sorted, I know that if cur is less than 0, well, I can increase the value of the cur next time by incrementing, I should say, the value of L. So if I increment the value of L, I know that I'm going to move up to the next, I'm going to move up the number at the next index over from the index that L is currently at is going to be either equal to or higher, or greater than, I should say, the number that we just had. So by incrementing L, we will eventually increase the value of our current, right? And that's what we want. We want it to approach 0 if current is less than 0. Now, same goes for the opposite way. If current is greater than 0, well, we want to try and find zeros, right? Because that's what we're looking for. So we can just decrement R. Now, if current is not less than 0 and it's not greater than 0, well, then we know that it must be equal to 0, which means to the set we can add. And notice how I'm using a tuple, and the reason why I'm using a tuple is because using sets, a list won't work. Lists are not hashable in Python, so let's just keep it in the right order. Lists are not hashable in Python, so we need to use a tuple. So we can add it to the set like that, and then once we're here, we can just increment L and then decrement R. And then at the end, we're going to return, let's create some space. We're going to return a list. We're going to convert the set to a list and return that. And yeah, I didn't use J, I used L and R. Yeah, that makes sense. So used to using J's in loops. Sorry about that. Okay. Okay, so there we go. We solved that one. We can see, however, that it's not very efficient. Like I said, there's a few ways to make this more efficient. But one way, which is going to basically really improve our runtime, is if at the beginning of this loop we find that we are at a number that we have already checked, we don't have to check it again. So we can just continue. And we're going to check for that by saying if I is greater than 0 and nums I is equal to nums I minus 1, we can just continue. So what is this saying? Basically, we're only going to check this if I is greater than 0 because, of course, we cannot even try to index this if this I minus 1 if I is equal to 0. So we first have to check that. And then if we've checked that, that's true, we go on to the next part of this sort of Boolean statement. And if nums I is equal to the previous number, well, we've already gone through that. We've already done that. And because we won't have duplicate triplets, there's no point in doing it again. We're just going to, waste time. So we can just continue. And you'll see that that should give us a more efficient solution. Okay, so yeah, definitely faster than the previous time. And yeah, like I said, there's other ways to make this more efficient. You can feel free to check those out, try and figure those out yourself. But yeah, that was day 79. If you guys enjoyed that, please like, subscribe. We'll be back tomorrow with day 80. Take care.